The last feature of IPv6 I want to talk about in our overview is neighbor solicitation. And I want to talk about this because it's a little bit different than what we do in IPv4. And remember, with IPv4, we rely on the ARP protocol, address resolution protocol, to find hosts on an individual network and map IP addresses to link layer addresses, so MAC addresses. And if you'll remember that discussion in our discussion of ARP, it relies on broadcast traffic. But an interesting thing about IPv6 is there is no broadcast traffic. That's not something that exists. IPv6 actually relies upon multicast addressing to achieve those functions. Multicast is just quite a bit more efficient rather than just broadcasting things out to everyone on the broadcasted domain. So that leaves us with an interesting question of how does IPv6 resolve its addresses to MAC addresses if there's no broadcast, if it can't rely on ARP, if ARP is not in its vernacular, so to speak. Well, the answer, as if the title of the slide didn't give it away, is a process called neighbor solicitation, which is a part of network discovery protocol. So to do that, we're actually going to rely on ICMP v6 and multicast. So ICMP v6 is a version of ICMP designed specifically to work with IP version 6, so it's not much different than normal ICMP for the most part. This reserved IP space is identified generally by having a prefix of FF00. So when you see that, in this case, we're probably talking some type of neighborhood solicitation. So I want to briefly just go through that process so you know what it looks like, and I'll actually describe the process a little bit and show you a packet capture that shows it going on in practice. The diagram on the screen now shows what normal stimulus and response looks like in relation to IPv6 neighbor solicitation. So remember to keep in mind here we're using multicast traffic and we're also relying on ICMP v6, which we've not talked about, but for the most part consider that it functionally works pretty much the same as ICMP v4 that we've already, or normal ICMP that we've already talked about in terms of it's a utility protocol. It helps other protocols. It has a bunch of different functions performing different things, not the least of which are things like pings, which we've seen, and trace routes and whatnot. But one of those is also, in this case, neighbor solicitation. That's all we have going on here. In this case, we have a client, and this client is a host with an IPv6 address of 2001.db8.121.003. So a little bit of a mouthful, that's what we're working with here. It wants to communicate with another host on the network identified by the IPv6 address 2001.db8.121.1000. So the source is 1003 in the last grouping, and the destination is just 1000 in the last grouping. Now, just as with IPv4, the source device must be able to determine the link layer or MAC address of the host it wants to communicate with, since this is intra-network communication. So in this process, the host 1003, so the client in this case, sends a neighbor solicitation packet to every device on the network via multicast. This is an IPv6 type 135 packet, and it's going to all the devices. So you notice it's going to the file server, it's going to the web server, it's going to the mail server. And it's basically saying, what is the MAC address for the device whose IP address is 2001.db8.121.1000. My MAC address is, and it gives the MAC address. So it's actually looking for a response to this. Now it's sent out to everyone via multicast. We've not talked about in multicast in depth, but it's a more efficient way to send out traffic than broadcast in this case. So it's sent out via multicast, and the only host that responds to that multicast request in this case is the actual true destination, is the web server, which is 2001.db8.121.1000. So that's the device assigned that IPv6 address. It responds to the multicast transmission. It does that using a neighbor advertisement, which is an IPv6 type 136 packet. And the packet basically says, hi, my network address is 2001.db8.121.1000, and my MAC address is 000C291FA755. So once this is done, the client now knows how to communicate with the web server, and that communication can now begin. So that's not too complex. It's not really that much different. It's still pretty much the same transaction type as would occur with IPv4 and ARP, but instead of using ARP, it's actually using ICMP v6. If that last example was a little too tricky for you to follow, don't worry, we got packets, and packets make everything better. So in this case, we have actually the exact same example I just showed via diagram, but we're actually looking at the packets that represent that example. So we actually, you'll see here, if you look at packets 3, through 7, we're actually pinging. We're pinging from a host ending in 1000 to a host ending in 1003. So this would be our client to our web server, going by the example we just discussed. So we wanted to do this ping, but before we could do that, we had to do this process of resolving the MAC address to IP address. And instead of using ARP, we use ICMPv6, which is what's happening with the neighbor solicitation and advertisement process going on in packets 1 and 2. So what I've gone ahead and done here is expanded the ICMP section, the header of packet number 1, and you can see here that this is a type 135 or neighborhood solicitation. Of course, it was sent up here from the device ending in 1003, and it was sent to the destination address up here, FF02. That means it's a multicast address. So it's a multicast stream with a target address ending in 1000. So the device we're concerned about, the device whose MAC address we want, is this device ending in 1000. 2001 DB8 121000, which is who we will eventually end up communicating with. The response comes in packet 2, and if I click into this, you'll see the information we're looking for. In this case, this was sent, remember that packet 1 was sent to a multicast, so it was sent to everybody. Everybody received that, but the only host that joined that multicast stream and responded back was the one we wanted to talk to. The source address here is the one ending with 1000, 2001 DB8 121000. It was sent back to our originator ending in 1003, which is our client. And we have a response, which is a neighbor advertisement, type 136 code 0. And in this case, we have our target address and we have the information we wanted, the MAC address of that target, which in this case is 000C291FA755. So now the source device, that the device in 1003, can put that in its cache. It knows how to communicate with that, and then at that point communication can actually begin, which is what we see beginning with packet 3. And we see that those, looking at the Ethernet header, those two MAC addresses are reflected here. It looks like we're going between an Apple device and VMware, so probably a virtual machine in this case. And I can verify that was the case because I generated this in a lab, communicating from an Apple laptop to a virtual machine, actually on that same laptop. So this is the neighbor discovery process. So we have the solicitation and the advertisement. Pretty straightforward. Again, very similar to the process that happened with IPv4 and ARP, but in this case it's IPv6 and ICMPv6 doing the work.